Hi all. Good morning, good afternoon, and good evening. So, in the first half of the class, we are going to cover data warehousing concepts. Right? In this, we are going to cover about introduction, OLTP and OLAP, and we have theories proposed by Inmon and Rolf Kimball, and we are going to see about data warehousing and data marts and star and snowflake schema, data normalization and dimension and fact tables, right? So let us start with about introduction. So what is the importance of data warehousing? Nowadays, everyone is talking about data. Hello, apologies. Okay. So if you see in the current world, each and every organization is adopting to the technology, right? Earlier, if you see, there are big organizations or organization that global level, they use it technology and they use it to collect their day-to-day transactions, information, all those things into the database and files, and they use it to pull the reports on it, right? But with technology evolving and government's focus on IT is changing, now mid-range, small range, each and every business units are using the technology, right? That means everyone need to have a system that stores their day-to-day transactions, day-to-day activities, right? And they need to be used for their business growths. Now, IT companies which are across the world, now they are giving services to these small companies, right? Because these small companies, they won't be able to create their own infrastructure, right? Now, when IT companies came to them, they said that, okay, I'm going to provide you a data warehouse solution, right? Now, what this data warehouse solution is going to make is, it's going to collect all the information generated as a part of their business activities, right? From the employees' salaries, employees' attendance, employees' well-being. Similarly, sales, how the sales are happening, day-to-day sales, monthly sales, right? Similarly, finance department. Like in an organization, there would be different departments would be there. If I simply show you in a pictorial representation, let me show you by creating a simple picture, right? Let me get a picture from online. At a time, I used to get very nice pictures from online. So that's why I prefer to have in the online, right? Ha. So what we are discussing, we are going to have our day-to-day business, right? Whatever the activity. If you go to the, if a customer go to the shop, he purchase something, then immediately we will get a bill. So that means there is a transactions happen. A bank customer goes to the bank and he applies for a loan. That means there is another transaction that have a information about loan application, right? Now, all these information would be stored in a particular databases, which we call them as a operational stores, because they are capturing their data operations, all the operations data, right? Now, what happened, if you remember, whenever we go to the Walmart or any Apple store, they would be having hundreds of stores and thousands of customers would be visiting them, right? So that means there would be some billions of records would be captured, billions of data. Now, operational systems would be focusing on to cater the services of the customers. They would be facing like a front end, right? Now, for the business, if they want to do a analysis of the data, right? Suppose if I want to do an analysis that what is my total sales for today, or say consider yesterday, what is my total sales for the last year, last month, last quarter. For this activity to do that, I need to scan entire data, right? Just in a simple thing, whenever you have a list of items in a table, right, you have purchased. Now, if you want to see what is the total expense that you incurred, then you need to sum up all those expenses. That means you need to read each and every record and you need to sum up. So there is a process, mathematical process happens, right? Now, for on these billions of records, if you're doing that activity also, then our operational systems will have a performance issues, right? So one way they are catering to the front office. At the same time, if you are hitting on them with a extensive analytical queries, then your performance may be degraded, which means they won't be able to cater the front office and subsequently customers would get impacted. Customer service would get impacted. Correct? So that is the reason two scientists, Ralph Kimball and Edmond, what they said is that, okay, boss, I'm not going to touch your operational systems. Okay, keep the data in your operational systems. Just give me a copy of those operational systems at the end of the day. Okay, say today business is closed at around 8 p.m. or 6 p.m. evening time, right? Now, what I'm going to do is I am going to take a copy of all the transactions into the staging layer. This can be also termed as extraction, right? Once I extracted this data, right? This data is in a way that would be helping for the operational systems. Now, what I'm going to do is I'm going to transform the data into a way that I can be using to analyze what is my purchases, what is my sales, and what is my inventory, right? And whatever the copy I have taken, I'm going to load into my warehouse, right? I'm not just doing a direct copy. Suppose today I have 1,000 sales. I'm going to sum up with the 1,000 sales and I'm going to capture one value, total day wise sales, total month wise sales. Similarly, I'm going to have the information about my stock that is present in my warehouse, right? At the end of the day, I'm going to get another report. What is the today's current stocks available in the warehouse, right? So that information I am going to capture on daily basis. So now I am going to see a trend. Okay, how my stocks are being reduced, varying. So if your stocks are reducing, that means your sales are more, right? Similarly, you need to order for the new inventory, right? And my understanding is we all about heard about the word called warehouse, right? Can anyone post in the chat channel what is your understanding on warehouse? So I just want to make sure that we are doing more interactive session. Okay. So can you help me whenever you heard about the term called warehouse? No, I'm asking general warehouse, Alekia. Let's don't come to the data, just a general warehouse. Storage, correct? So we are going to store all our raw materials, right? Or finished goods. A storage, a warehouse is a place where the stock is kept, right? Whatever the finished goods is there. Suppose if market is not good. So if we are selling now, then we may incur a loss. Then what we will do? We will store them in our warehouse, right? So that when the market is good and prices are high, then we can sell the product. Similarly, when it comes to the raw material, whenever we are getting our raw material on a cheaper cost, then we will purchase them and we will store them, right? So this warehouse acts as a storage for our products. Similarly, same thing, data warehouse is also a kind of warehouse that stores all our data in an organized way, right? So are you clear with this one? Because what I want to is I want to just clear the blues, right? That data technologies, data tools, they are not something a rocket science. If we slowly interpret with our regular uh, surroundings, then we can easily understand the things, right? So what I can say is a data warehouse is a collection of data, right? That we clean, transform, and load it into it so that we can use for our operational and business purpose, right? And the data that we collected, we are going to store based on the functionality, say purchasing functionality, sales functionality, or inventory functionality. And these would be used for analysis, reporting. Suppose if you have a operational employees, they just want to see how the data, I mean, how the inventory is there. For them, reporting is fine. And management or senior leadership, they want to analyze the data. So they are going to analyze that one. Similarly, mining is like data mining. This will helps to project the future forecast, right? So I have a small article from Amazon. So what it says, a data warehouse is a central repository of information that can be analyzed to make more informed decisions, right? As a part of our assignment, I am also going to give you the articles. Those are handpicked after reviewing multiple articles. So they would be the best for you to gain the knowledge. So I would request you, whatever the articles that I am providing in the assignment, that you are thoroughly watching them, right? A data warehouse is a central repository of information that can be analyzed to make more informed decisions. So this is the key point we need to hold. Okay. Whatever the latest cloud technologies or data mining, data analysis, whatever that comes, right? All are used by the management to make the informed decisions, right? Now data flows into data warehouse from transactional systems, relational database, and other source, typically a regular consent, right? If you see this diagram, right? So operational systems or transactional systems. Why we are terming it as a transactional system? So I'm going to explain you that one. Let me complete this better, right? Typically on a regular business analyst, so we, the Power BI developers, data engineers, data scientists, and decision makers access the data through BI tools. So BI tools means it can be a Power BI or it can be a Tableau reports or any other SQL clients and other analytical applications, right? So data and analytics have become indispensable to the business to stay competitive, right? Now, if you heard about this word, data is the new oil, right? Nowadays, business, politicians, even things are being driven by the data only, correct? So if you want to give any speech in the international forums, first they are doing lot of analysis with the help of data, whether it's a World Economic Forums or geopolitical situations or wars. Even within the war, even wars also being driven by data only, right? Lot of data they analyze. They analyze the maps, they analyze the images, and based on that, they create their strategies, right? Business users rely on reports, dashboards, and analytical tools to extract insights from their data, monitor business performance, and support decisions. Data warehouse power these reports, dashboards, and analytical tools by storing data efficiently to minimize the input output IO of data and deliver queries results quickly, right? So how is database architectured? So what are the benefits of data warehousing? Informed decision making, consolidated data for many sources. So if you see here, you can be having many sources, but I am going to keep a consolidate information. Even in the Power BI, once we pull all the data from different sources, I can show you how it looks like, right? So next one, historical data analysis. So this is very important, right? So a data warehousing is going to maintaining the history of the data. Now, what is mean by history of the data, right? Suppose we have a student Abdul, right? Now Abdul has his home address, right? Now he is in Sydney today from last 5 years, right? Before the 5 years, he would be in the Melbourne. Before that, maybe he is in Perth, right? Now operational systems, if they are storing this information because of exponential increase of data, their performance may be reduced, right? And definitely for our operational systems, they really need what is the current address of Abdul, right? So in operational systems, we are going to store only one record, that is Abdul's current address. But in data warehousing, we are going to store his previous addresses also, like putting a effective start date and end date. So that tells from which date to which date where he is staying, right? So in this way, data warehousing is going to be used for historical data analysis, data quality, consistency, and accuracy in the data warehouse. That's why whenever we start our Power BI reports, right? If our source, which can be a data warehouse or any other databases also, if the data is well organized and provided to us, then half of our work is done. Okay. Separation of analytical process from transactional databases, which improves performance of both the systems, right? So this is what we discussed. The first and foremost benefit of data warehousing is it separates the analytical processing. That means the business or strategic planners who want to do some analysis of the data, that process would be separated from the transactional databases, which improves performance of both, right? Now, we are terming about operational system, or we are saying transactional system, right? So the databases which stores the transactional information or the operational information, we are calling them as OLTP, online analytical processes, right? OLTP, online analytical process. So this part is going to be an online analytical process, right? Similarly, the process or the systems, those are going to be used for analytical purpose. We are calling them as OLAP, online analytical process. Very simple, easy explanation. Nothing doubts, no doubt on this one, right? So there are two parts. One is OLTP, online transactional processing. These systems make sure all the transactional information is stored, and online analytical processing is going to store the data or system that are required for the analysis processing, right? Now there may be some criterias also. Suppose if you consider a online analytical processing, right? What happened? It's going to be stored. Suppose if you take in a bank database system, it is going to have millions of customers. But at one point of time, a single customer comes to the branch and he says that this is my customer ID. I want to know so and so information. That means within fraction of seconds, the teller or the cashier who is sitting there, that he should be getting only his particular record, right? So online transactional processing mainly focuses on small amount of data, getting small amount of data in a faster space, right? Whereas online analytical systems, right, they would be used for the data analysis. That means they need to scan all the data. Either if you have 1 million customers, then you need to scan and you need to answer questions like what is the total sales, what is the total customers, whether you have a profit or loss. So analytical systems mainly required huge space to store the huge amount of data and also processing capacity to store lots of process, right? To do lot of processing. Now I have a two charts from the window. Let me see. Oh, thank you very much. Transactional processing. I'm happy my students are actively listening. Online transactional processing, OLTP, OLAP. Thanks, Evo. Please, can you update it? Thanks for Angry VC. So up there, you have mentioned OLTP wise OLAP, right? So you want to know what is the differences between both of them? So that is
I
what
just,
we,
sorry, I just wanted to point out you have written
that is
OLAP
fine.
in place of OLT. It's
Okay,
all good.
thank you. Thank you very much. Thank you. Thanks for students are very active.
OLTP
Okay.
is the operational side, transaction side, and OLAP is the warehouse side, right?
Analytics side. Yeah, correct.
Thank
Okay.
you.
Yeah. And our data warehousing, reporting, business intelligence, these comes under the analytical parts. That is the reason if you see our role says that business analyst, right? Or be a data analyst associate. So we do the analysis part. So I would request you now you just think in your day-to-day world also. Just think of it. Okay, I'm doing daily expenses. Let me calculate what is my expenses. Okay, I'm earning something in a different channels. So let me get together and see what I'm going to get like that. I think someone is using their keyboards or something. I'm going to provide you this information. Okay, don't worry about it. I'm going to get you desktop. DWH, right? Now, if you see, we have a data warehouse, database, and data lakes. So we need to understand about these terminologies, right? So first of all, we see the databases, right? Whenever you want to store any information, any kind of information, a list of items, the first thing what we do, we create a list, right? Name, cost, items, something like this, correct? And we create a list of items. So then we are going to add 1, 2, 3, 4, right? This is the basic fundamental thing we are doing from our childhood. Same thing you are going to do in your data analysis, right? Either you may store in the tables or you may store the information in a form of some items or objects, right? Now, if you are storing the data in a form of tables, that means it would be the combination of rows and columns, right? Now, these tables are stored in the database, right? And the companies like Teradata, PostgreSQL, Oracle, SQL, Amazon, now they are providing us the solution of these databases. And we call them as database management systems, right? In a simple, we can say the tools or systems where we store data in a form of rows and columns in an organized way, right? Whenever you are terming a database, that means you defined a structure, right? You created a database for a bank like Citibank, and you said that I need a table called customer table. I'm going to store the customer information. So within this, you will put customer ID, name, address. So you would be able to store that information specifically, right? So if you see, typically business uses a combination of database and data lakes and data warehouses, right? Now, wherever you have the option to store data in an organized fashion of tables and columns, we call it as databases, right? Data warehouses also same thing. As I told you, data warehouse is a concept, but the underlying solution is provided through the databases. And they would be more organized because we're telling, right, we are going to consolidate data from many source system, historical data, data quality, consistency, and accuracy. So information or data that is stored in data warehouse, they are going to have a good quality, consistency, and accuracy. Similarly, data lakes, right? We heard about the lakes, right? Lakes. There would be different lakes, rivers. Whenever you see a lake, right, in the nature, you would be seeing different items in it, right? It has the stones, it has the natural habitat, plants. You don't see one thing, you would be seeing wide variety of things in a lake. Similarly, if you have a solution that is able to store your data in the form of tables or in the form of files, images, XML files, anything unstructured, right? So you can store any kind of structured and unstructured data. That is the reason whenever data lake comes, we put as a cloud symbol, right? So if I see the, let me take this one. I come to back to the Excel. If we say the databases, a database is going to have a structured data. Structured means it is properly defined, right? We first define in each and every database, we first define how it should be sitting. This is the symbol that is used to represent a database. Now, a database is going to have a proper structured information in the form of tables like this. Okay. Each table can be storing a customer information or a employee information or product information, right? Now, if you are taking a data lake, which means it's a kind of a cloud. Where is our cloud symbol? Here it is, like this, a bigger cloud. How to get the shape fill? Automatic, no fill. Okay. Now in this cloud, along with the databases, the cloud has a capability to store individual files. This is the representation of files. We can store the data in the form of files, right? In the form of images, anything we can store. Say, if I take normally images, right? These are like semi-structured or unstructured. Structured means we define, okay, this particular thing should be residing in this way. Okay. So whenever we call it as a cloud or data lakes, so they have the capability to store the data in the form of structured and unstructured also. Okay. So we'll just pause here. Any doubts with respect to data warehouse? Can you post it in the chat channel? Is it clear with the understanding? Because my basic thought is that people should be very clear and confident on the basics. If we are strong on the fundamentals, then we can easily learn the tools for every, whether it's a construction of building or learning something new. Fundamentals is very important. If we know the fundamentals clear, then subsequent topics we can easily understand. Okay. So can you post in the chat channel any doubts or queries? Okay. Do we need to create the storage or it comes Power BI or it come Power BI? Now, Power BI is going to connect onto the different systems, okay? And it gets the required information data and then it will create the reports, okay? We don't need to create explicitly storage. Fine. So now we have seen OLTP and OLAP, right? Now we will see the theories of W.H. Inman and Ralph Kimball. Now in the data warehousing, we have two legends, right? Who are they? Ralph Kimball and Inman, right? Yeah, W.H. Inman. Now, what they said is that they have proposed a design like Newton theories, right? We have three theories, and Newton has kept his name. Similarly, Ralph and Kimball, Ralph Kimball and Inman, they have kept their names for their theory. Now, let us see what they are saying. Let us see first one. The design of data warehousing is essential part of business. For designing, there are two common architectures. So these are the two common architectures, right? And which one we are going to use. Now what it says, the Kimball is saying that design a data warehouse by Ralph Kimball, right? So Kimball approach is designed by him. The approach starts with recognizing business process and questions that data warehouse has to answer, right? Now what Ralph Kimball says that we need to first figure out, sorry, what is our business processings, right? So if you see the diagram, this will clear your doubts. So what Kimball says is that first of all, you need to define your business processing. Suppose if you see an organization is going to have a HR department, right? Human resource department. Similarly, you are going to have finance department or manufacturing department, right? Now, Ralph Kimball, what he said that now you just create a small data marts. Now, what is mean by data mart? Data mart is also a data warehouse only, right? There is no difference between data mart and data warehouse. Data mart is same as data warehouse, but data mart is a part of data warehouse, right? Suppose if you take this example, right? What happened? We are going to have a data from all our transactional processings, right? At the end of the day, the finance department would be having, say, 10 or 20 files, which is having the information related to what are the expenses and what are the incurs. Similarly, manufacturing department is going to be having a data related to the total productions, how many employees attended to the office, right? All those things, how much inventory is used. Now what happened? Their respective data files is going to be sent to their data marts, and here we create a data mart related to the finance, HR and manufacturing. And once we have individual data marts are created, then we are going to integrate all this as a single data warehouse. So this is what Kimball proposed. So what Kimball has proposed, so it's a kind of like agile methodologies. If you remember, I mean, someone in the Scrum or Agile, what it says that divide your project into the uh, what we call them, into the achievable modules, and then implement them. Those we call as user stories, right? Similarly, when it comes to the organization, definitely we are going to have a departments, a marketing department, a finance department, and there would be a lot of data based on their day-to-day activities, right? Now we would be taking one department and we start preparing data mart for them. Similarly, once data mart prepared for the marketing, then we go to the finance department. After that, we will go to the manufacturing department, right? Similarly, once all the data marts are prepared, then we will integrate them into single data warehouse. So that would be used by the reporting layers like our Power BI, right? What is the benefit of this approach? Set up and build are quickly. The reason because we'll go to one single department and we will understand that business processing of that department and we will start creating, right? Generating report against multiple star schemas very successful. So we are going to have each and every data mart on that we can pull the reports. Data operations are very effective considering it would be lesser in size, occupies less space in database and management is easy, right? So this is what Kimball proposed. Now what Inmon is saying, now Inmon saying is that this Inmon saying, he says that no, not about the department level. Let us create a data warehouse at the organization level. That means at the corporate level. So if you remember, if you take any of the wider organization, you would be having head office, right? That is sitting at the capital or somewhere. Or if you take a government, we are going to have our central government or state government, like federal government and state governments, right? Now what Inmon says is that no, you don't prepare any single data marts at the department level. There may be chances it would be repeating lot of information. Okay. So what it says that now please create a data warehouse at the corporate level like this. Now what Inmon is saying that you get all the data, create a central data warehouse. We also call it as enterprise data warehouse or enterprise data platforms also, right? So what it says is that if each department is preparing their own data marts, then what we observed is there is a chances of redundancy, right? What happened? Marketing team creates a employee table, manufacturing team creates an employee table. That means you are having two employee tables with repeated data within the organization, right? So that is the reason what Inmon says is that now what I will do is I will pull all the department heads and key subject matter experts at one boardroom, and I will create an architecture for the data warehouse at the corporate level. Now make sure all the data is cleansed, transformed, and loaded it into data warehouse. Now each department take their own data mart and create a cubes on them, right? So are you clear with both the architectures? You can post it in the chat channel because this is very important thing which I want to make sure that you are clear. So Inmon and Ralph are two architectures, and they proposed this solution in 1986, like Newton's theory, right? Which is still intact, and we are using that one even though we are in advanced because they are like fundamental. Similarly, Enmon and Ralph Kimball, their theories are, their architectures are still intact, right? So one architecture says that each and every department build their own data marts. Now let us integrate that one into a data warehouse, right? And vice versa. Okay. Angry says that Inmon says the better one. Okay. Thank you very much. So in general, both are better one. It's about what is your organizational appetite. Some organizations would be simple. So what they prefer is go with the data warehousing. Some organizations would be at the complex structures. It's very difficult to pull everyone at the center table. So wherever that kind of situation happens, they will go for the Ralph Kimball. So it's a case by case. Now, for this one to better understanding, let me show you the differences. If you see here, introduced by Kimball, introduced by Inmon, approach. So Kimball approach is bottom-up approach for implementation. That means from the department levels, each and every department's prepare and it will goes to the central organization level. Whereas Inmon is top-down approach. Correct? Similarly, data integration, it focus on individual businesses. So that means as we discussed, like our Kimball focuses on each and every a marketing business. Suppose if you are entering into the new business, you are already as a part of power plant where you have a coal feed power plant, but now you want to move into renewable energy, solar or wind. Then they are going to have their own data marts, business lines. Whereas Inmon says that at the enterprise wide, it is efficient and take less time, right? Because we will go to one department and sit and understand, and all the department people they are going to sit at one place. So it would be less time. Similarly, in Mon it is a complex, right? And consumes a lot of time because the first thing is we need to get all the heads from each and every area to one place, and there is a lot of brainstorming is needed how it can be integrated. It is a iterative and steps and is cost effective, right? You don't need to have more investment in Ralph because it's a iterative. Initial cost is used and development cost is low, right? Here initial cost would be used to getting everyone's and creating an architecture, right? And also getting, but once you have that architecture ready, then you don't have a duplication of tables and everything. So that is the reason development cost would be less. It does not need such skills, but generic team will do the job, right? If a finance department is there, then IT guy can sit with them and they can work on it. It needs specialized skill to make work. So it's not about department and an IT guy. We should have a person who can integrate the departments, who can put the plan on the paper. Correct? Here maintenance is difficult. Yes. because each and every department, they create their own data marts, tables. That means it's very difficult. There is no central control on it. But here maintenance is easy. It prefers data to be denormalized. It prefers data to be normalized, right? So we have one topic, right? Data normalization and denormalization. Guys, now I want all of your attention, okay? Because we are going to see data model. Now what Kimball says that it is having a denormalized model, whereas Enmon is having a normalized model, right? Now, before understanding this term, I just want to give you a small example. Let me open one data sheet that I prepared for our class. Here it is, right? Are you seeing this table? This is a sales table, okay? Now it is having the information about the product name, customer name, address, and whatever the information about the sales, right? Did you got this table, all of you? Is it clear? Because I just want to make sure this normalization and denormalization is very important topic. It's going to be traveling with us till we are doing our data analyst job. Okay. Ha. Now, if you observe one thing, here my name is getting repeated. Similarly, Michael name is repeating, Dirk name is repeating. Similarly, my address also, right? Now think of an organization or a Walmart store that is near your house, right? Now you go regularly to that shop. So suppose in a month you go some 10 times, okay? So that means your information is going to capture repeatedly 10 times, right? Now in your area, like you, there are around 1,000 customers going on an averagely 5 times. Then those 1,000 customers information would be repeated. Will you agree with me or not? So if you are storing your data as it is in a single table, because whenever you are enter into the store, whenever you give your phone number or customer ID, they immediately search it and they should get all the information. They need your address every time, right? So that only they can deliver the product, and they also know, right? But what happening, think of it, if the data is being stored redundantly, and we know to store this data we need lot of hard disk, and that don't come off free of cost, right? Again, there would be charging. We need to go to market and purchase a rack of hard disk, and we need to put it. Even if Google or Microsoft providing, they are going to charge for us. But what we are paying for the data we are storing, that is redundant or duplicate data, right? So if you are storing data in a redundant way or single table, then we call it as a denormalized. Okay. Now, why Ralph Kimball is having a denormalized model? Because each and every department creates their own data mart. In my department, I need to maintain employee table. Similarly, in marketing, they need to create an employee table. Now, there would be common employees also there. So that means information about Jilly or Adinkya or someone would be having at the both the places. So that is why denormalize, right? Now, what the data stewards or data architectures or Inmon, what they said that boss, let us don't keep the data in one table because it's we are wasting lot of our disk space. Okay, what we can do? Okay, let us do one thing. Let us distribute the data into multiple tables, right? So wherever you feel that I am going to enter particular information repeatedly. Suppose customer is there. We are going to store customer information. Customer address is required. And customer is going to come multiple times into my store. So what I'm going to store, I'm going to create a customer address table and I'm going to store all the customer related information. Customer name, address, city. So whenever I want to refer him, I am going to refer just with his customer ID. Here it is. See, right? Similarly, whenever I want the products table, right? Let me minimize this one. Because whenever we go to shop, I am going to purchase the same product. Say if you take the milk or meat, hundreds of customers are going to purchase the same thing. Similarly, instead of every time for me writing the customer product name, I am going to store the product information in the product table, right? And I'm going to give a unique number for this one. So while storing this data in the transactions, I'm going to store only their reference information. Now, if you compare with the denormalized table and normalized table, here suppose I may need around say this would be 6 characters, 6, 12, something around 40 to 50 characters. But I'm going to save this as similar information in 4 characters or not more than 6 characters or numbers. Now just think of it. Something an address I am storing at 20 characters, but I'm just storing in 1 character. Not just about one person address, say 100 customers would be there. Now all these 100 customers, I'm going to store their address one time in the address table and I'm going to refer this address ID multiple times here. Now whenever I want to fetch the data, pull the data, I'm going to redirect to my query to other tables and pull that information. It's like this is going to be my key. Yes, I have a locker in my master bedroom, but that key I have safely stored in other room, right? In that way. Now storing the data into multiple tables in a organized and relational way, then we call it as normalization. We are normalizing our data so that we reduce the data redundancy. And these tables are interconnected. They are have a relationship. That is the reason whenever we coming it as a database, then we call it as a relational database management system. RDMS. Relational database management system. We are going to learn more about this one in our PostgreSQL, right? Further, if you see in the customer address also, I know that city name is going to repeat. Not about city name like city name, state, country. That means I don't want to repeat this Texas multiple times. So further, I will create a city ID column, right? And I will relate this to the cities table. Okay. Now here you should be having a unique record for Texas so that whenever customer address table want to pull a city details having a city ID 1, then it is going to pull Texas. And this particular column should be unique and not null. This is also termed as primary key. Okay. So having these relationships, now let me show you one interesting image for you. Insert a picture. online. Star schema. Oh, something we got Chinese. Sorry for that one. Insert. Ah, schema. I hope I should be getting something in English. Yeah. Now, if you see this particular table, and if you are interpreting with our normalization concept where we distributed data within multiple tables, right? Now, if you see, this table is going to have a transactional information, right? That is about the facts. You done today one activity or one transaction or one observation. So that means a facts is captured, a transaction is captured. So the center table, we call it as a fact table. Similarly, the reference table which we are using for this fact table, we call them as a dimension tables, right? Now, fact table is going to store the activities or observations of an organization or any company. Now, the surrounded dimension tables, right? They are storing the information related to the entities, persons, or products, right? If you see these tables, you will be having the product information, product name, categories, texture, cost. Similarly, here you are going to have customer information, city information, right? So I'm telling in a simple natural language. The tables that stores the activities or observations are termed as fact tables. They would be sitting at the center, and the supporting tables which stores the information related to the objects, products, persons, they called as a dimension tables, right? Now, if you see this relation, it looks like a star relation. Let me get another image. I think in one of the, let me get this one from here. Yeah, star schema design. This is what I want. I'm going to share you all these links also, okay, as a part of our assignment. Yeah. Now, if you see, this sales table is the center one, and it is supported by other products table. So those are called dimension tables. And if you see, it looks like a star. So that is the reason a fact table surrounded by the dimension tables for one level, we call it as a star schema, right? Similarly, just in case a dimension table further having a relationship with another dimension table, that means one level down, like parent, child, and grandchild, then we term it as a snowflake schema, right? So if you see, a detailed, nice explanation is also there. Dimension table stores business entities, stores events or observations, includes key columns and descriptive columns for filtering and grouping, include dimensions, key columns, numeric values. Typically contains fewer rows. A dimension table is going to have a fewer rows because just kind of employee information, product information. They don't change frequently also, right? Contains numerous rows like transactions, observations. And dimension tables used for filtering and grouping. whereas fact tables used for summarizing, right? So is it clear what it mean by normalization? If we see, we have seen a journey. I mean, from Ralph Kimball and Enmon, we figured out normalization and denormalization. So I explained what it mean by normalization and denormalization. From this, we again learn another topic called star and snowflake schema. And also we seen facts and dimensions, right? So introduction, OLTP, OLAP, Enmon, Ralph Kimball, data warehouse, data marts, stars, snowflake, data normalization, dimensions, and facts, right? So this is all about our fundamentals of data warehousing concepts. Okay. So I will pause the class recording